the deadline, because I want people to learn from the homework, right? It's not there where I penalize you for unsatisfactory work like I do with exams. Now, the exams you have no choice because we have to have a measurement of how well you have acquired the required knowledge, right? But homework, quizzes, they're just a preparation. So I will do whatever it takes to make sure you use them to learn rather than to be apprehensive of what grade, or if you don't submit, you're gonna get zero, or no. And even the results themselves, I'm not interested in the final result. If I have to help you, I will help you, because I want you to understand and use that knowledge then to show me how good you are during the exams. And that's what will count the most, right? Because you will have a limited amount of time, confined environment, limited amount of resources, and so on and so forth. And if you can perform in that situation, then that's it. You have at least been approved for having acquired what is required of you. So make sure that, whatever difficulties you have, you let it be known, right? You don't keep it to yourself, because the less you learn, the more frustrated you become, and it will impact other things in your life, other courses, a job prospect, the behavior in the workplace, the behavior at home, because whenever we are emotional, it will show everywhere in every situation, right? So let's keep some control over it and be practical, right? That means when you have a question, you ask it. Don't keep it to yourself. Don't be embarrassed, right? Because you don't fill your gap, and people, of course, will appreciate that, because they would be behind and they would be ahead of you, not because they're better than you, but because you didn't fill your gaps, right? So if you have no questions, then I'm gonna go to the back to the PowerPoint and finish up the whatever. Question 25, like you tell me, ask me, right? The thing about questions, I am more effective and efficient when I try to fix your problems rather than giving you a solution. You know what I'm saying? Because if I give you a solution, you're just gonna read it, you say, oh, I get it now, and that's it. But you'll never learn, because if I give you another problem, you will struggle. But if I see the way you struggled and then I correct those points, you will remember them better. So Nicholas Carreon, are you able to share your screen with us so we can find out? Oh, please do. Okay. All right. That's exactly what I was going to say. All right. So you're the presenter. Please do.
Hello?
Yes, I can hear you fine.
Hi, Professor. I just wanted to make sure that you heard me.
Oh, yes, I
Um,
do. I can hear you fine. Very well. I love the microphone, by the way. It makes it better than just the chatting through words.
I'm trying to figure out how to share my
All
screen.
right, so you go to the purple thing, and then when you extend it, you have an icon which is a box with a curved arrow. When you click on that, it says share screen or whatever. One of the menus, share screen or application. So click on that one. Then it's another window, and then you click on the MATLAB application itself. That's what you're going to share with us.
Okay, I think I got it. Can you see?
I think you did, because I see it. All right. So first, there is a problem regarding the problem itself. The problem itself has two steps. One is you have to solve the problem. That means come up with a solution to the problem as a mathematical solution. Then you program the solution. You know what I'm saying? So now, in your case, you decided to show the data, which is the area and the width. But then you're asking in line 45, of course, theoretically, I don't understand why it's line 45. That means you're trying to combine programs together. You shouldn't do that. I told you that I want every program to be a unique file. You can combine the publications, but you shouldn't combine the programs into one single program. That's for sure. Secondly, in line 45, you're asking to find capital A. I don't know what capital A is. If it means the area, you're asking to find the area, but the area is given, it's 80. Second, which is even worse, right? Meaning that most students do that, right? They ask MATLAB to evaluate the area, which is the width times the length, but they don't tell MATLAB what the length is. So MATLAB is going to say, what is the length? What is L, right? It's unknown variable or file name. I don't know what that is. You cannot ask MATLAB to evaluate anything unless you give it before you give it the values of the parameters or the variables you're using, right? Then you on the left side of 47, it's kind of an expression. To you it means W square, but to MATLAB it means an expression. It's W square. There can never be an expression to the left of the equal sign. You can have a variable, but not an expression. You cannot have AX plus B equal. You cannot have anything to the left of the equal sign except a variable to be evaluated. And on the right side, it has to be something that MATLAB knows, right? It has to know what that is. Like in this case, D. What is D? MATLAB does not know. Did you give D before? No.
No.
You know what I'm saying? So now ask the class how to start fixing the problem. Not specifically the MATLAB expressions. That's secondary. The first one is how to solve the problem. Obviously, the problem was about what? What is the question again? Nicholas.
The question was, can you see my screen?
No, but you can read it to us. Not read it, but you can say it in your own words if you want.
It's asking, so basically it says they're giving us the width and they're giving us the area, but they want us to find the length of L in an enclosed area, and they give us like a
is that the length, like L or the perimeter?
Yeah.
Or both.
And they're stating to us that no, we're just looking for where they want us to find L.
L, that's it, the length. Okay.
Yeah. There's write a MATLAB script in terms of the given variables W and A to determine the length L required to the enclosed area is A. And they gave us like a drawing of it says around the ELB shape. And there's so regarding the expression, I put W squared equals D squared plus D squared because I saw that there's like a triangle, and in the problem it states that W, since it's the horizontal axis, it's symmetrical with the triangle. So I kind of thought, oh, that's Pythagorean theorem. Like I was just doing like in terms of math.
Yes, in terms of math, you have the right. Like on a piece of paper, that's what you should do because it's part of the way you're going to solve the problem. So you write the expressions that will make sense. Right? But then, mathematically, what you should do is you should put on the left side what you don't know. And on the right side what you know. Meaning that you want to find D in terms of W. Not W in terms of D. Like here, when you write W on the left side, it's really the D expression that should be on the left side. But again, it's not about MATLAB. It's about on a piece of paper, right? You should put D on the left side because this is what you don't know. And W, you know. So anything you know is on the right side. Anything you don't know is on the left side. That's how we deal with algebra, right? Okay. The same thing with A equals W times L, right? Unfortunately for you, that area does not represent the area of the whole field, right? Because small a equal 80, that's the whole field. Whereas capital A is the area of what, in your case?
Just a part of the field.
Part of the field, which is a rectangle.
Yeah, the rectangle.
Right. So the problem now is we need to know how to solve the problem first. Ask them if they have any suggestion.
Do you guys have any suggestions on how to find this problem first. Well, I want to see the tags here. Does anyone have any suggestions?
They're not participating, are they, right? I mean, that means you have to figure out a way to encourage them, to motivate them, right? Because just asking like this in a very timid way, very nice way is not good enough, right?
Yeah.
So what do you think?
Can anyone explain to me how to start off with finding I got the area, the triangle part I got covered, but I don't know how to continue from there. You guys can type in the chat if you guys don't want to use your mic.
Hard to get people to
anything,
right?
Yeah,
I know. Imagine when your parents try to get you to do something and you don't do it, huh? Now you know what it's like, right?
Yeah, I guess.
Let me just for a short period of time. I know, right? Yeah. That's. Well, how come we? Thank God Nicholas has asked that question. Otherwise, every one of you is going to mess it up by tonight and give me something that doesn't work, right? I'm not interested in things that don't work. I'm interested in things that do work, because that's how I pay your salary. I can sell it. I don't care how beautiful it is, but it works. I can sell it. So let me just for a few seconds, take over, if you don't mind, Nicholas, and then I get back to you.
Yeah.
I would like to show the steps needed. And in this case, I'm going to use the same thing that your friend has used. And I'm going to follow his way, because I have different ways of obtaining a solution. I am not here to show you my way unless it's really useful, meaning that my way is the best way and you should learn it to do that way. Right now, I'm interested in, did you find a way? Did you make it work? If your way is not efficient, but at least your solution, that's good enough. And someday you will want to improve your ways. Why? Because if it takes 1 hour to solve the problem or 10 minutes, well, 10 minutes is better, because then I don't have to pay you for 50 minutes extra, right? So if this is W, this is L, and this is definitely W. And if we said that this is D and this is D, one thing that I can help you figure out is that this is a half of a square, right? Because these are equal. And 90 degrees, then obviously this is the same, and it's exactly, this is D, this is D, this is 90 degrees, that's a square. However, I will follow your friend's lead, which is think of Pythagorean theorem, right? So what he wrote is W square equal D square over D, is that D or D square over 2? No, it's D square, right? Plus D square. I don't know why you had D square over 2, but oh, maybe because you had the half here or something. But theoretically, Pythagorean theorem says this is the hypotenuse square is equal to the side square plus the other side square. So, and again, I'm interested in D, not in W. W is known, it's given. So the way I should have written it is D square plus D square equal W square, which is 2D square equal W square, and D square is equal to W square over 2. Of course, I can also write it as D over W over square root of 2, but for the time being, I don't know which one is going to be useful to me, right? Either one of the two. Anything you want to talk about right now, at this point? Any question you may have? Of course, you don't have to say, no, I don't have any questions. If you have a question, you ask. After 10 seconds, I'll just move on. Okay. The second expression is people gave you the area. I'm going to put it on the left side for the time being, right? But of course, later I'm going to move things, because what is unknown, I should want it in the left. What is known should be on the right. So I say the area, that's the area of the rectangle first, which your friend wrote as W times L. And of course, this gives me a chance to tell Nicholas, don't get confused by using small case and capital case at the same time. You have to be consistent. Either W is capital W or W small w, but you cannot have two of them, small w and capital W. Same thing with other L or capital L or small l. You have to be consistent. So here I use capital W, I use capital L. And I use small a because you use small a, right? So that's part of, and then this area here. Now, as I said, I can think of this area as the half of a square, and half of the square, that means the square is d times d, and then that's d square, and then half of the square, that means d square over 2. Or I could use the area of a triangle, right? Which means I can think of this as the height. This is the base, right? Height times base divided by 2, right? Same thing, right? So don't try to have the height here and the base is here. Use this as a base and this as a height, right? Something like this, right? Right? You can think of this as the base, this is the height. Or I can say it's half of a square. In either case, the area is d times d divided by 2. Right? Base times height, d times d over 2, or d times d divided by 2, that's half a square. So it gives me the same thing, right? So now, if I rewrite this w times L plus d squared over 2, but I know that d squared over 2 is w squared over 4 from this, right? So I can rewrite it as w times L plus w squared over 4, because d squared is w squared over 2, then divide by 2, that's divided by 4. So now, and this is A. Hey, I know A, I know W, I don't know L. So I have to figure out how to move L to the left side. So in this case, if I wrote W times L, that's equal to A, then I move this to this side, which means minus, because when you move it to the other side, you change the sign. And then I say L equal A minus W squared over 4 over W. And this is what you program in MATLAB, because now you have the unknown, everything on the right side is known, and that's top set, right? That's it. Agreed? Nicholas?
Yeah.
Good. So now let's get back to you, young man. So I assume if I were you, I should, because I'm going to get this paper off the screen, since we have to switch to Nicholas. And that means all these derivations, you should have them on a piece of paper on your side. If you haven't written them, too bad, you're going to be in trouble, because you should learn to write as you go, especially when it's useful, right? Or at least so that you can understand what changes we have to make and what we need to do to solve the problem. Right? So I'm going to give you 15 seconds. Okay, I'm talking to everybody, of course, you know. So in 10 seconds, I'm going to switch back to in fact, yes, that's it. Now I'm going to shut off my screen and ask Nicholas to go back on. Nicholas, are you back?
Yeah, I'm just trying to share.
I know.
Okay.
I'm just reminding you. Yeah, accept share application. Okay, good. Okay, so again, can you make the command windows a little bit smaller by making the editing window a little bit larger or whatever? All right. So go back and provide the A and W like you did before.
Oh, like I did it before?
Yeah, A equal AD, W equal whatever, you know. Semicolon. On the same line, because we learned to put the data in one line, it makes it a lot easier to see the program. Later on, of course, for yourself, you can put them separate line. You can put comments about what the units are and so on and so forth, right? Or what they are, like A is the area of the field, W is the width of the field. You know, that's for you, right? You should, because next time if you see this program, you know, 50 years from now or 50 days from now, you may not remember what A is and what W are, right?
Yeah.
What A and W are. So next line is straight up the solution, because I solved the problem already. I know that I'm looking for L, and I know the expression for L. So the only thing you have to write is L equal, and you write the expression that is written. Do you need those parentheses, Nicholas? The last ones you put in? No, the last ones you put in.
Um, I don't think I need. I don't think I need this one. I don't think I need actually. I just need that one.
I think that would be a problem. Why? Ask your friends why this is a problem.
Why is this a problem? Why would I have to take away or add those extra parentheses?
I think maybe they're tired. Maybe they didn't go to sleep. Maybe they're asleep right now in front of the screen. Do you think?
I don't know. I think they're just shy. It's the same thing for me.
I know. You maybe you're probably silent if your screen was not on, showing. But still, that's. Let's see how you can get them to wake up, man, or to participate. And when I say wake up, it's just for me to use something controversial so that they feel offended and they say, no, I'm here.
Shouldn't the parentheses be outside of the A?
Tell him why, though.
Because if not, it's just going to divide everything. So, for example, you want to keep everything together since that's the numerator. So you're going to have A minus the width squared over 4. So that's all the numerator. So you want to put that in parentheses.
Absolutely. A minus W squared over 4, that's the whole thing divided by W, not just W squared over 4.
Yeah, so put the
When you
parentheses.
remove those parentheses, and the ones that are around W squared over 4, they're not wrong, but they're not needed. Because if you look at the order of operation, first the square will take place. I mean, MATLAB first looks at the parentheses, right? But then within the parentheses, it's going to square W first, divide by 4, then A minus W squared over 4, then the whole thing divided by W.
Yeah.
Which is the right order of operation, which is what we want exactly in this case. So temporarily, remove the semicolon so that when we execute, we can see the value, and your friends can copy it and use it to verify. Right? Check it out. Means execute it. It's going to ask you to save it, and then whatever it is, and so on. And do you think that your friends found that number? You can make that one smaller, yes. And anyway, theoretically, I want you to put back the semicolon, because I'm not going to help you with the third step, the third line, and that's what I want you to display the result in a sentence with the units, right, with the proper units. That we will not do. That's going to be your problem, right? Because that's simple enough based on what you did before, so you should be able to do it easily. But at least you know what the value is. And you see how much work I had done on a paper just to establish one expression that I want to ask MATLAB to evaluate. The good thing about it is that if the field changes values, like if the area is 150, if the width is 55, I execute it again, one fraction of a second, and I get the new result. That's the beauty of MATLAB. I can do it 10,000 million times, and it will be extremely short as compared to the hand calculations. But to be able to find the solution for MATLAB to use, I had to do some derivation on paper, right? That's your brain. Your brain solves the problem. MATLAB helps you calculate. That's all it does. It makes it easier. Ask them if they have any questions for you, Nicholas.
Does anyone have any questions? Let me just put something in the chat.
Well, Christian says no, so.
Oh, okay.
But as I said, as a rule, just give them 10 seconds. If they have nothing, that means they have no questions, and we just move on.
Mm-hmm.
Okay? Got it?
Yeah.
All right. So now I'm going to go back to lecturing then, if there are any more questions. Otherwise, of course, there cannot be any more questions, at least based on this problem, because when Nicholas disappears, no questions will be asked. Thank you, Nicholas.
Thank you, Professor.
Welcome. Now I'm going to go back and share my own PowerPoint. Okay. Here, and again, I remind you that we are dealing with an introduction, a basic introduction to MATLAB. That means in this chapter, you see a little bit of everything. but not in detail, right? So just to give you an idea of what MATLAB is capable of, and when I say MATLAB is capable of, this is not even 1%. Even if you spend the whole semester together, it's not even going to be 1% of what MATLAB can do. But it gives you at least a possibility to enter that field, and maybe someday you will use 10% of it. Most of us have never used more than 5 to 10%. I guarantee you, if I'm lucky, I will use 10%, if I'm lucky at all. Because there are so many things, so many routines, so many functions available, and in so many fields, tens of fields. So I'm sure I'm not going to get into possibly genetics. I'm not going to get into accounting, maybe, right? Maybe not. And even in engineering, I may not get into mechanical engineering, or I may not get into electrical engineering. I may be interested in specifically, let's say, civil engineering or industrial engineering, because already in that field, there are hundreds and thousands of possibilities available already, let alone the problems that I have to solve myself, or I decide to research. So the point here is that as soon as you open one door, more doors will be available, and you open more doors and more doors will be available. So that means you will always improve your ability to use this package, this program, to help you deal with more and more complex situations. And that's what matters, right? So we start with the basics, but it will help open more doors of more complex situations. So in this case, we're going to be learning on how plotting can be useful in terms of graphing a variable versus another one. Because as we say, a picture is worth 1,000 words. So sometimes that graph can tell us exactly the behavior of some variable with respect to another one. Whereas we're looking at an expression, I don't see much of it, right? I don't know. I'm not so sure that I can say how the behavior is like. So in this case, when you want to plot a function, you need to have multiple points. X, Y, X, Y. Those points in a graph are just a connection between points of X, Y coordinates. So I decided that I'm going to graph these functions, there are two of them, in between 0 and 4. So that means that the minimum, sorry, in this case, I need the pointer, which I don't have. So I need to plot my function between 0 and 4. And I decided to select an increment of 0.001. So before I go on, I ask you a question. How many values of X did I generate? If you remember what we discussed last week. How many points do you think I have generated through this arrangement? Do you remember the expression that is used to find the number of points? Anybody? You don't have to type it in. You can just say it through the microphone. Otherwise, I'm going to say, you went home and you never opened your PowerPoint. You never opened your book. And that means here I am, making myself sick about trying to figure out how to get you the best information, but you're not doing your job. Of course, it may not be true, but I may be tempted to think so. So please prove me wrong. No. Do you see it now? This is A max, this is A min, this is the increment, and you just evaluate this. So what is the number of points? Ah, merci, David. Thank you, David. Obviously, if you don't know how he got it, that's your problem, because you should ask him. And if you don't ask him, I just move on. So there are 401 points. And I think that's good enough to plot a smooth curve. Why? Because if you remember, MATLAB just puts a straight line between any two consecutive points. And if you have enough of them, it would look like a smooth curve, like a logarithm, like an exponential, like a sine wave, whatever. It looks smooth, right? But really, it's a bunch of straight lines. That's all it is. But if they're narrow enough, if the space between two consecutive points is small, you will not see straight line. You will see as if it's like a continuous curve. In this case, obviously, we're going to learn different ways, right? And in this case, I could have written y like line 2 instead of this line 2 here. First, before that, I would have said y1 equals sine 10 pi t. y2, another line, equal cosine 10 pi t. Then I would write t y1, t y2. That's one way. Or I could put it straight into the function, meaning that MATLAB will evaluate this for me. And if you remember that if t is an array, that means it's 401 values, this here is going to be evaluated for every value of t. That means there will be 401 ordinates or y values, right? 401. So there is 400 values of t and then 400 values of y1, 401 values of y2. Second, something that we will discuss in the last topic, here I added another thing that so far you don't have to worry about, especially when we're doing it online, is I'm forcing the first plot to be red. I could force, but since the second plot I didn't say anything, MATLAB decides for me what color to choose. And in this case, it chose blue. But I could have forced it to become yellow or to become any other color, right? Which we will learn about in the last topic. Otherwise, MATLAB will always make sure that the two graphs, in this case there are two of them, will show in two different colors. It may not be your choice, but it will definitely use two different colors automatically. Unless you have some color in mind, then you force MATLAB to accept it through these apostrophes, and in this case R, which stands for red. Again, in topic 5, we will see more of that in the future. Second, theoretically before, we said plot ty1, and then if I want the second plot, plot ty2 as a separate line, right? As a separate line. But if I do that, if I say plot ty1, then the next line I say plot ty2, it will plot the first one, but then a microsecond later, it will replace it with the second plot. The first plot will disappear. So writing it this way, which means in the same plot function, ty1, ty2, ty3, I can have multiple plots, right? They will all appear on the same set of axes. You see here the same set of axes, and I have two graphs, right? On the same set of axes. I think last week we learned a different way, which says plot ty1, then hold on, then plot ty2. That's another way to force MATLAB to put them on the same set of axes with the usage of hold on. In fact, instead of doing all this, why don't I use MATLAB? No. Why do I do that? I'm gonna go back to Nicholas. Yo, Nicholas.
Yes.
Can you please share your screen with us? And let's see if you can write things as I say them rather than me just typing them, right? And hopefully you make mistakes when you write them down so that we can debug, right? Because if you do them correctly, there's nothing to talk about, right? So, okay, so the screen is yours. Okie dokie. All right, so let's start with the important thing here. Of course, later on, I'm going to explain why specifically I discussed the 0 to 4 range. Why is it useful to me? What the numbers in those expressions represent as far as sine waves are concerned. Even though it's about math or algebra or whatever, but it's nice to know, because if you don't know, you're plotting things and you don't even care what it means, right? So let's start with the first line, which is t equal, varies between 0 and 0.4, and the increment is 0.001. So I have said it this way. Let's see what you can write, and let's see how your friends can help. So I want you to generate a range between 0 and 4, and the increment is 0.001.
You said 0.04?
No, I said between 0 and 0.4, but the increment is 0.001. When I say point, that means 0.001. That's what it means, really. Ask your friend, man.
I can't really hear you that well.
You have a problem with the keyboard?
No, I was trying to raise the volume.
Ah,
It said point. It said something about 0.4. I'm not sure. I didn't hear you well. 0.4. And then what else did you say? And did you increment
so
of how
the
much?
increment is 0.001.
0.001. I'm not sure how to write the increment. I know how to write the range, but not the increment. Can anyone help me with that?
0.001. Yeah. Ask your friends if this is acceptable.
Is this acceptable?
It would be nice if you guys. All right. And David said no.
Okay.
What do you suggest, David?
Oh yeah, semicolon.
What else? Okay, not comments for sure, but what else? It's A min, increment, A max in that format. The way you wrote it is A min, A max, increment, right? It should be A min, increment, A max. And in addition to the colon that David talked about. And then you don't need the brackets. The brackets are only when you have a bunch of numbers which do not follow each other, like a pattern like this one. Here, the way we generate this with numbers that are incrementing by the same amount, we don't need the brackets. And semicolon because we don't want to display 401 numbers, right, on your command window.
Mm-hmm.
Okay, next one. Instead of writing it the way it is in the slide, because you already have the PowerPoint, so you can check it out, see a different version. Let's write it differently. So first, y1 equal, and we express what the first function looks like. y1 equal sine 10 pi t. Sine, parentheses, and everything in between parentheses is 10 times pi times t.
10 times pi
times
t,
t.
you said?
Yes.
Okay.
Semicolon. Second one, next line. Same thing, but y2 equal, and this time it's a cosine. The same argument, but it's cosine. Very good. Now I have two ways of writing it. So next line, you can write it as plot in between parentheses t comma y1 t comma t comma y2. T comma y1.
Can you repeat that? I couldn't hear you.
As you're plotting both. So t comma y1 comma t comma y2.
T comma
y1
y1
comma t comma y2.
T comma y2. Okay.
In this case, go ahead and execute it as is. And you can say sine test, sine test or sine plot as a title, whatever you decide. Okay, you wait until the figure comes. And if it doesn't come, then bring it to wherever the screen is. Bring it to the front so we can see it. But then you're sharing MATLAB, so you have to figure out how to share the graph. Is there a way for you to share the graph or?
Yes, there's a way.
Yep. And you have exactly the same plot that I had, right? But it's just written differently. Now go back to sharing MATLAB. And you see the colors? They're again kind of red and blue, right? So which means MATLAB will use two different colors. The reason we need to learn more about the way you plot things is because when the class used to be conducted in the classroom, they only had a printer to show their work, and the printer was black and white, laser printer, right? So we could not use the colors to decide which plot is which, right? So we had to figure out different ways, right? So, but right now, put the percent in front of line 4. That means instead of doing it that way, we want to do it differently. Then, line 5, write plot TY1. That's it. Except you wrote a 0, not an O. Or capital O.
Yeah, no, I wrote capital.
I know, right? TY1. Close the parentheses, go to the next line. But now I want to plot the other one too. But the problem I told you before, if you plot them, just plot, it's not a good idea because the second one will erase the first one. And you will see only the second plot only. So to force MATLAB to put them on the same set of axes, we're going to use the directive hold on. So just hold on, 2 words. And then next one is plot TY2. And execute. And show us the graph, which of course theoretically, you don't have to because it's the same anyway. I mean, you can just verify. You don't have to show it because it's the same as before. And you see here a third way.
The other window, but
Yeah, it's fine. I'm saying you don't have to show it. I mean, people, if they do their own stuff in their own computer, they will have access to it, right? They will know what it looks like. And it's exactly the same as the one from before. So I'm just showing you 3 different ways of making sure that the same plot, 2 different graphs will appear on the same window. You can put it as one single plot. You can do Y1 and Y2 separately. Well, in this case, it's not really a separate plot command, but it's just that I can make the expression inside the plot command, or I can do it outside. Here it's outside, right? Y1 is evaluated outside the plot command, and Y2 also. Or we can use 2 single plot commands, but I have to have a hold on in between. Hold on, that means stay with the same set of axes and plot the second one. That's what it means to MATLAB. Stay within the same set of axes. Let me show you how. Not in this case, of course, it's not useful, right? First of all, when I'm going to ask you, Nicholas, but then it's not like you have to answer, right? The whole class is in. When you look at a sine wave, which part represents the amplitude of the sine wave, and what does that mean, the amplitude? What does the amplitude of the sine wave mean to you guys? And the sine wave, it's either sine or cosine. We call them sine wave, right? Which part represents the amplitude, and what is the amplitude? Not just the height, it's the maximum, right? The maximum level it reaches, right? So yeah, I know what you mean by the height. I understand you, right? But we're just going to say it's the maximum value that the signal will reach, which happens to be 1 y. Where does it appear in the expression? Yo, Christian, come on, man. We haven't heard your voice. Maybe we heard it, but a very short period of time, It's the number that multiplies the sine or cosine. And what multiplies sine or cosine? Right, the coefficient. Well, the coefficient in this case is not really coefficient. It's the, yes, well, you can think of it that way if you want to. But it's the number that multiplies sine, that means to the left of. And it's 1 times sine, 1 times cosine. That's the amplitude. Otherwise, if you put 2, then the maximum height would be 2. 2 sine, the maximum height would be 2. That's the amplitude. We call that the amplitude, right? So in this case, we obviously chose to be 1 and 1, right? Now, the number that multiplies t is called the radian frequency. The radian frequency, that means the frequency is defined as the number of times the signal, in this case the sine wave, repeats itself in 1 second, right? So, but here, because we're talking about the radian frequency, not cyclic frequency, so it's associated with the number of times it repeats itself. Nicholas, don't go away. I'm gonna take over, but I want you back, right?
Okay.
I hope I don't mind. You don't mind if I abuse you more, right? So please, right?
No, that's fine.
All right. So let me first then deal with the camera just to have an idea. So in this case, when you have a cosine omega 0 t, sine, cosine doesn't matter, right? It doesn't matter, right? And again, remember what I said, a is the amplitude. So this, the maximum height, that's a, the amplitude. Now, omega 0, which I said is the radiant frequency. And of course, when you deal with vibrations, even if you don't deal with electricity, but we deal with vibrations, those in many cases, those vibrations are sinusoidal in nature, right? That means they're like sine waves, right? Sometimes they're a combination of multiple sine waves, but most of the time it's just a single sine wave of interest. So we call it the radiant frequency because it's given by radian per second, right? But the one that we are more aware of is the cyclic frequency, which is F0, which is omega 0 over 2 pi. And that's given by Hertz, which means kind of cycles per second, or CPS. And there's also a period, which is the inverse of this cyclic frequency, or this is usually what we call frequency, and this we call radiant frequency, just as a standard, right? So the period, it means from here to here. Why? Because after that, it just repeats itself, right? The inverse of the period is the cyclic frequency. So for example, when you look at the electricity in your outlet, it's called, it's a sine wave at 60 Hertz, which means 60 times per second, it repeats itself. 60 times per second, it repeats itself. And so in this specific case, 0 is equal to 10 pi, right? It's equal to 10 pi. Therefore, F0, which is omega 0 over 2 pi, which is therefore 10 pi over 2 pi, that's 5. That means it will repeat itself every 5 times per second. And since it repeats itself 5 times per second, from 0 to 0.4, obviously the period here, t0 is equal to 0.2 seconds, right? Because it's the inverse of this. And that means from 0 to 0.4, there are 2 cycles. I will see 2 pieces of the sine wave, right? 1 piece, second piece. And that's why you saw the sine wave there with 2 cycles, right? Because we chose our range to include 2 periods, right? 2 of these, 1, 2. Are you happy with this information, Nicholas?
Yeah.
Okay, so again, someday it may be useful, and most likely this semester too, but in your future, you will have to deal with this situation. So go ahead, go back to your screen. Okay, I'm going to give you a different way of presenting your plot. Again, those are just introductory, right? Just to get you used to it. Let's say I want them graphed in different plots, in different figures completely, right? So in this case, put the percent in front of hold on. Then go to the next line. Not from 7 to, from 6 to 7. Insert a line after 6. And I want the second plot to be in a different set of axes altogether. So one way of doing it is to write figure 2. Figure, F-I-G-U-R-E, and 2 in between parentheses. Now I'm asking MATLAB to plot the second one in a separate figure. The first one by default is figure 1. And so in a separate figure, figure 2, and it will appear as a separate plot. They're not going to be together. They're going to be separated. So go ahead, execute, and hope that we can see your screen with the, in this case, if you can share your screen. Otherwise, of course, the tunnel effect is so annoying. That's why I have two screens in my case, so it's easier to share that way. When it's not the main screen. So if you had 2 monitors and you share the secondary monitor, it's very easy, right? But when you have to share a monitor where the display is and your packages together, yeah, see the tunnel effect. So you see if you can share the, yes. Or we can see figure 1, figure 2. I mean, yes, that's it. Very good, very good. So you see here that now they are appearing in separate plots. Agreed?
Yeah.
Ask them if they have any questions. If not, we're going to move on to doing some more things with it.
Any
Nothing?
questions?
And then 10 seconds and you move on and see, did they have, yes. Okay, let's go back to your screen, go back to MATLAB, that is. All right, so now what we're going to do is put a percent in front of everything and remove the percent in the first one that we did, the first percent, right, which is in front of the whole plot. So remove the percent in front of line 4, and put the percent in front of all the other lines, right? 5, 6, and 7. No, 5, 6, 7, and 8. Now what I want you to learn is few things. One is we're going to call how to label the x-axis. So go to the line 9, because we have to tell people what x is, right? And we're going to be able to say it through something called x label. So x label, XLABEL, that's a function from MATLAB, right? Parentheses, because every time you use a function, you have to remember parentheses. And in between apostrophes, because now we're going to give it a string, right? A sentence, words, right? String, characters. So we use apostrophes. Every time it says text, it's in between apostrophes, right? And the apostrophe is next to the enter key. Yep. And then you type in, let's say, time, comma, s, meaning the time in second. Time, comma, s, meaning that's the unit, right? Close the parentheses. That's your x label. I can put it in the same line, or you go to the next line. For the y, I'm not sure I want to do anything because there's two different graphs, so I cannot label y label because it's two separate things, right? But if you wanted to label the y-axis, like when you have just a single graph, you can say then the height in meters or whatever it is, right? Whatever y is, right? You decide, right? So you do the same thing with the y if needed, y label. But in this case, oh, you forgot to put the apostrophe, sorry. Apostrophe before.
I wasn't sure.
Yeah, you see now it turns purple, which is correct, right? Now, then another function that is useful is title, T-I-T-L-E, title. And the same thing, but now we give a name to the entire graph appearing at the top. That's the title. So again, in between parentheses, apostrophes, and we can say sine waves. Except when we say sine waves, usually sine, E, S-I-N-E, and it's one word, sine waves. No space. That's it. Then another one that is of interest in the future, when you have multiple graphs, and then somebody looks at your graph and says, which one is which? I can see blue, I can see red, but which one is which? So in this case, we have something called legend, L-E-G-E-N-D. That's another function. And again, parentheses, apostrophe, and everything. But this time I have two graphs, so I have to give two kind of subtitles to the different functions. So since we plotted the sine first, we're going to just say sine, meaning the first signal will be the sine, and the second one will be the cosine, right? So sine, apostrophe, comma. That means now I give a second name, right? And cosine. Apostrophe, parenthesis. Now execute it and see how it tells us which graph is which, right? Of course, you have to show us the graph, but the same as before, but now we have additional information. So you see now at the bottom for the x-axis, you see time, S. You see the title sine waves on top. And now you see the blue is sine and the red is cosine. So now we know which one is which, right? And it makes sense, right? Because the sine at 0 should be 0, and it is, right? A sine function, sine 0 is 0, right? So it makes sense, right? But the legend is the one that tells us which graph is which. So it's very clear. Again, here MATLAB uses the colors, but if you had the black and white printer, we would have to use different styles to plot the graphs. Not necessarily continuous line, it has to be different. Otherwise, since the colors cannot appear on a laser printer, we use different styles. But that's what we will learn in the end in topic 5, right? Ask them if they have any questions, because I'm gonna keep on lecturing.
Is there any other questions?
Thank you, Nicholas. I'm going to ask you a favor. And of course, you know, I'm going to abuse you more by saying this. Not abuse you by more work, but unless you find me another volunteer to share his or her screen, I'm going to have to keep you working with me, because that's the easiest way.
No, it's fine. It's fine. I actually, this way it's more easier for me to learn.
Okay, good. Well, at least people are hearing you. Maybe in the future, if they want to learn, maybe they should learn to volunteer to share their screen, right?
Yeah.
All right, so let me go back to my PowerPoint. So I'm not going to discuss whatever. I'm going to discuss the next one, which is the only case in this semester where I will talk about matrices. Well, in PowerPoint, maybe I will mention them in the future. But the only case where I really deal with them as a problem, as an application, as a solution through MATLAB and so on. So we start first with a problem where you have 3 people, right? 3 people whose age are X, Y, and Z. Today we have 3 people. Hopefully not me included, but I'm old enough to be part of the lot, right? 3 people whose age are X, Y, and Z. Then it tells you that the sum of their ages today, if we add all the ages together, is 126 years. And in 10 years, the person whose age is Y, so the Y guy or gal, doesn't matter, Y person, will be twice as old as the person whose age is Z. But 12 years from today, the person whose age is X will be twice as old as the person whose age is Y. Okay, that's a lot of words, but it hurts my head trying to figure that out, right? So let's figure out the equations. It says the sum of their ages today is 126. Good. That's the way you write it. The sum equal 126. Then it says 10 years from today. Well, 10 years from today, the person will be Y plus 10 years old. And the Z person will be Z plus 10 years old. That's their age at 10 years from now, right? However, it says the person whose age is Y in 10 years, which is this, will be twice the age of Z in 10 years. And so, of course, the same thing here. The person whose age is X, 12 years from now, would be twice the age of the person whose age is Y today. And, of course, this is his age 12 years from now. So here we wrote equations that represent the information that was given to us. Before I go on, we have to make sure you understand these equations, right? Do you disagree with these equations? Is there something that bothers you in these equations? Because if you don't understand them, who cares about what we do later? Even though in real life, it doesn't matter what the problem is. The only thing that matters to MATLAB is that you put the equations in a way that it can work with. That's all it matters, right? Who provided them? How did they put them in that form? That's not your problem. But sometimes it is, right? Sometimes you have to solve the problem before you can ask MATLAB to do the calculations. So just for the sake of curiosity, does anybody have problems with these equations? This is 10 years from now, twice as old as Z 10 years from now. Because 10 years from now, it's Z plus 10, right? That's the age. Okie dokie. All right, so now the problem is, I want to write my equations so that on the left side of the equal sign, I have every term that is X, Y, and Z. And on the right side, only numbers. Only numbers. And in this case, this is the way. So if you play with the equations that I had given, if you put the X, Y, and Z on the left side and the numbers on the right side, I assume that you have enough algebra in your skills that you can find these equations to be true. So now what you have to give MATLAB, it's two arrays. One, it's made of the coefficients of the left side, and second one is the one made from the coefficients of the right side, or in this case, the constants. So if you look at the coefficients, you see here 1, 1, 1. That's the first row. Here there is no x. That means the coefficient is 0. 0 times x, right? 1, negative 2. 0, 1, negative 2. And the coefficients here are 1, negative 2, and 0 because 0 times z. And on the right side, you have 126, 10, and 12. But it has to be presented as a column vector. This is a two-dimensional array. 3 rows, 3 columns. Because you have 3 variables, so it has to be 3 rows and 3 columns. And the right side, it has to be a column vector with 3 elements, right? Because there are 3 equations. So now, as far as MATLAB is concerned, you present the first. In this case, I'm going to use the word matrix, if you don't mind, because it's going to be a matrix operation, right? So the first matrix or array is made of that first array A. 1, 1, 1, the first row. See here, separated by comma or space. It's up to you. I like commas because it's very clear, the separation between the numbers. Then semicolon. Why semicolon? Because I want this row to be the second row. If I don't put a semicolon here, if I put comma, it'll be just the same row forever, right? So to say it's the next row, not the same row, but the next row, I put a semicolon. And then again, a semicolon, and I put the next row. For the column vector, I have 126, but 10 is in the next row. So that's why I use semicolon here. This forces it to be a column vector. Why? Because 126, you go to the next row, then it's 10, you go to the next row, then it's 12, right? Semicolon means go to the next row. And the operation that gives the solution is A backslash B. You remember I told you that backslash, which should not exist, which in arithmetics, it means really B divided by A, right? But in the case of matrix operation, it means find me the solution of the equations that we had given before. Here I just present A and B, right? But I know on a paper it was really 3 equations and 3 unknowns. And MATLAB will give you the solution, right? Give you the solution. So now you know why the backslash has been created. It's not really B divided by A, but I will explain later, right? In the next PowerPoint, I will explain why it's written that way, what it really means, what MATLAB will do instead. It's not B over A. It's not like you divide the array B divided by the array A. That kind of operation is not valid in matrix operations, right? But I will explain why they had to create this backslash symbol as an operation or operator. Obviously, I presented you with the display. I did not put the semicolon here, so that the solution will appear as 3, right? Yeah, because you have X and Y and Z, right? So it's 3 different values that need to be created, because it's 3 equations, 3 unknowns. So it's the arrays have 3 rows, 3 columns, and 3 columns. So the solution is going to be a triple set of numbers, right? However, I call that output age, the solution, right? So age is going to be made of 3 numbers. Here I'm listing the first number, which in my case is X, right? Of course, because I provided the first equation, and when you look at the equation, it's always X, Y, and Z on the left side, right? So the first solution is X, the second solution is Y, the third solution is Z, right? Because of the way I wrote the equations, right? The coefficients. The first is about X, the second is about Y, the third about Z. So the solution will be presented in the same way. So in this case, if you remember how to point to an array, right? Age is an array with 3 numbers. So age 1 means give me the first element of the array, which is really the age of X. Give me the second element of the array, which is the age of Y. And give me the third element of the array, which is the age of Z. And so in this case, as you see here, if you add them together, you get 126. In 10 years, 34 will be 44, and 12 would be 22. 44 and 22, twice the age. So we get to verify it, right? This is how, and the only time this semester that we get to see matrix operations. We will deal with array operations, but in the format of element by element. We'll call it element by element, which we will learn about in this second topic. But as far as matrix operations, this is the only time we're going to see it this semester. So, and the rules are different, right? The rules are completely different. That's why one has to be careful when you deal with the matrix operation or array operation. When I say array, sorry, it means element by element. The way we write them down will be unique to each one, right? Otherwise, it cannot be mixed, because otherwise MATLAB will say, is this a matrix operation or element by element operation? So we have to be clear, and we have to write them in a specific way. Obviously, we learned about comments. I already told you when you needed to publish how to. We learned about display. Input, I don't want to learn about it yet. And the reason is that when you use it, it's good when you work with a monitor. But when you want to publish documents, it becomes an obstacle because you have to interact with the program, where occasionally it says MATLAB will execute, will find the result, and put the code and the result together in one single document. Of course, you can't do that because you have to. So I try to avoid it for the time being. But in the real life, we're going to use it at least once or twice this semester just to show how useful that function is. Because if I write a program and I tell and I say to the students, hey, put your name in there, and it will tell you what grade you have, right? So I'm not going to display the grades. I have to know who asked for it, right? So I say, here's the program, input your name, and then the grade will be displayed. Your grade will be displayed. So the input statement will be useful then, right? With examples. So otherwise, you know. So are you ready to do something similar? So what I'm going to ask you to do is create your own problem with the same thing, right? But instead of changing just the numbers here, let's make it two steps. One is just to change the requirements. Let's say instead of 10 years from now, make it, let's say, 5 years from now. Instead of 12 years from now, make it 15 years from now. Something like that, right? And write it down as equations, then fix them to make it look like this slide, right? To make it look like this, and then produce the A and B, put them in. If you get numbers, real numbers, then your problem has a solution, and the solution is whatever the numbers are, right? If you get complex solutions or whatever, that means your problem is stated in a way that there are no real solutions. That means it cannot be true. Because there are sometimes, you know, some solutions say, yes, 5 years from now, these guys can be double the other one. But when you say the other third guy is double that guy, that's not possible. So you gave me a problem that has no solution, right? So let's see if you can prepare a problem like that, put it under XYZ, on the same form, and then produce the solutions based on that program, which you can type in. The second one that I want you to create is instead, in this case, you don't have to create a big problem, but I want you to create a set of equations with WVXYZ. WVXYZ. That means you have to write 5 equations, 5 unknowns, but you don't have to write them. The only thing you have to do is create this A to have 5, 5, 5, 5, 5, right? 5 sets of numbers 5 times, right? It's like this, but instead of 3 rows and 3 columns, you have 5 rows and 5 columns. That means 5 variables, right? And of course, B will have 5 elements. It's a column vector, but it has 5 elements. That means 5 equations, 5 unknowns. And look at how fast MATLAB, 3 variables, 5 variables, and if you have the courage to go with 8 or 10 variables, it's still a fraction of a second and you get the result. Can you compete with that? Never, ever, ever. I mean, 5 variables will not be lost there for the next hour. Imagine 10 variables, yeah, in my dreams. Even if I know methods to do it by hand, it will take forever. So this is the power of machines. You cannot compete with it, so you have to learn to use them. Otherwise, you will be obsolete, because nobody's going to pay you for taking time to do things that the machine can do in a fraction of your time. So 2 things. One is create your own problem, still 3 equations, 3 unknowns, but change the parameters. And the second one is create some array A and B, which can deal with 5 rows and 5 columns. You don't have to create the problem. You just change the set of numbers, right, with 5 rows and 5 columns, and see what kind of solutions you get. You can just type in the same program, but in this program, you know, you don't even have to type this. You just type H equal. That's it, right? You don't need these sentences. We just want to see that I can do it, and if it's a different case, whether I can find out if there is a solution or not. And the second case, how fast the machine can do the job, even when the arrays are bigger. And of course, if you have the courage to go to 20 rows and 20 columns, and you will see that MATLAB will still do it in an extremely short period of time, maybe 1 or 2 seconds at best. And that's a major achievement, man, because I tell you, even if I have confidence in your calculation, you'll be there until who knows what, a week from now before I get to see the result. I guarantee you. Okay, so let's do it, and then we'll meet again in 10 minutes or 15 minutes. But in 10 minutes, maybe I will start asking somebody. I know Nicholas has been very kind and he's willing to be involved, but still, if you hear his advice that he learned more by participating than just by listening, this is your time to get involved. And if you don't get involved, then Nicholas will be a better learner. Not everybody. I mean, some people say, no big deal, man. Right? But if you think you can learn more by participating, especially heeding Nicholas's advice, then do it. All right. See you in 10, unless you have any questions right now. No questions? Adrian, you sure? Adrian, you have a microphone, man. Talk to me. Are you there? Shafiq, are you there? Oh, yes. But I like to hear the microphone, Adrian. You had it on before. Well,
yes, Shafiq here.
I know. I can hear you. I love to hear your sounds, guys. I mean, I can find out how excited you are, how helpful you are, how demanding you can be, and so on and so forth. Remember, you got to be nice. But if you're too nice, it's not good. That means you will never ask for anything. All right. See you in 10 minutes.